examples. Here's one. It says, assuming that the births of boys and girls are equally likely. So that, first of all, tells me the probability P is 0.5. Now, we're looking at calculating the probability that all the children are boys. There are exactly 2 boys. There are more than 4 girls, and so on. So for this trial, the probability of success, what we're defining as success, is having boys. Okay? For this trial, we're going to, again, define the probability of success as being boys, because we're looking for there's exactly 2 boys. Down here, now the success is girls. All right? Or you can leave it as success is boys and go 1 minus the probability. All right? That's not to say that actually means you're more successful if you have boys. I happen to have 4 boys, so I'll tell you that that's a success, because that means I'm successful. But it's not really. It doesn't really matter whether you have boys or girls. But in our trial, we have to define what is success and what is success is what we're measuring. So we're trying to measure, are all the kids boys? Okay? Seems like this is frozen. So how many trials are there? That's the other thing we have to decide, and it tells us that right here. There's 6 children, so that means that N, where to go? This is getting all finicky here. N is equal to 6. All right? So if I want all the children to be boys, I am going to say I want X equal to 6. So I'm going to go to my calculator. You can go into menu, go to statistics, go to distributions again, go to binomial PDF. The number of trials this time is 6. The probability of success is 0.5. And we want to know what's the probability at all 6. And the answer is 0.015625. Very unlikely, which we kind of know. It's very unlikely that in a family of 6 children, they're all boys. Now, my first cousins actually happen to have a family of 6 children that are all boys. Not very likely to happen. If you look at the next question, it says, what's the probability there are exactly 2 boys? So we're doing the same thing, except we want the probability that X is equal to 2. And what I would suggest is to go up in your calculator, just copy this over, and so you just hit the up arrow twice and then hit enter, and just change this to a 2. Okay, because we just want to know what the probability is that it's 2 instead of 6. And we get 0.234375. Then it says, what's the probability there are more than 4 girls? All right, so if there's more than 4 girls, it means that there's either 1 boy or no boys. So you can find, if we're sticking with the boys, we can do CDF. We can go up here again, just take your arrow, just scroll up, and we're going to change our lower bound to 0, and we're going to change our upper bound to 1. All right? But we have to correct this because we changed trials and we changed probability. It's up to you. You can just go into the menu, go to binomial CDF, and plug it in again. I'm just trying to give you a little bit of a time saver. So 6 trials, percentage or possibility of getting a boy is 0.5. We want to know what's the probability that there's up to 1, which means the rest of them are girls, so 4 girls. It says more than 4, which means it's either 5 girls or 6 girls. So there we go. There's our answer. All right? And then the final one says the probability that there are more boys than girls. If there's more boys than girls, we need to have at least 4 boys. Okay, so again, you can do 1 minus the probability that X is less than or equal to 3. That's one way to approach it. Or you can just go in here, scroll up here, and change your lower and upper bound. So my lower bound is now going to be 4. My upper bound is 6 because I want at least 4 boys, and I can have as many as 6. And there's my answer. It's 0.34375. And that's how you do binomial distribution. Now, there's more complicated questions, and we'll talk about some of them, but that's the idea. All right? So we'll go through some more of these in class. Here's another example where it's talking about a local bus service. There's a couple ones that have to do with colds. I'll go through the rest of these questions in class. You just need to understand the concept. Okay? So we'll go through these 2 in class. I'll leave them up here if you want to have a look at them. Just pause the video and you can look at what we're going to do, but we'll do these questions on Monday together. The other concept that you need to know about is the mean and standard deviation. So if it's a binomial distribution, the mean is just n times p. It's the number of trials multiplied by the probability that they occur. It's very easy, very simple. And that's all you really need to know. That's the mean. You don't have to remember much else. And then the standard deviation becomes the square root of n times p times q. So if it asks you to find the mean, it's just the number of trials multiplied by the probability of success. It's just the average. And the square root of npq is the standard deviation. So here's just a quick example. A fair die is rolled 12 times. X is the number of sixes that could result. So you either get a 6 or you don't. The probability of getting a 6 is your probability of success. So it's 1/6, and it's 12 times, so it's 12. So you go 12 times 1/6. We expect to get 2 6s. The standard deviation is the square root of 12 times 1.6 times 5/6. That's the probability of failure, right? That's the probability of not getting a 6. And we just get our answer, and that means we expect to get a 6 rolled 2 times with a standard deviation of 1.291. All right? So that's how you find the mean and standard deviation. Here's another example. Bolts produced by a machine vary in quality. It says that the probability that it's defective is 0.04. So there's your probability of success. That's P. We're taking 30 bolts. We want to know what the mean and standard deviation are. So 30 times 0.04, that's my mean. It's a pretty easy calculation. It gives me 1.2. The standard deviation is n times p times q. So q, because p is 0.04, q is 0.96. And there's our standard deviation. So we're going to do some more practice. There's a lot more questions to look at, and we will go through them. Some IB questions to look at as well that are binomial. That's the concept of binomial distribution. So we'll talk about the questions in class. As long as you have the concept of how to find a probability using binomial PDF and CDF on the calculator, you should be good.